let's see the properties of the root locus. So now we know that we have a transfer function where we have Ts equals to kg over 1 plus kgh. So this is the closed loop transfer function. Alright, and from this transfer function we know that we have the characteristic equation given by delta S equals to 1 plus kgh equals to 0. Okay, this denominator equals to 0, we call it as the characteristic equation. And we can represent actually this 1 plus kgh equals to 0. So we take the 1 to the other side where we have kgh equals to negative 1 plus j0 equals to m, and we have angle theta. So actually we can represent kgh in terms of complex number, Cartesian form, and we have another one in polar form. We have magnitude and we have angle over here. We can say that from this, the value of S is a closed loop pole if M equals to the magnitude of kgh equals to 1. Okay, the magnitude of negative 1 plus j0, so we take with this magnitude of this complex number, we will get 1. 1 square plus 0 square, square root of them equals to 1. So we have M equals to magnitude of kgh equals to 1. And the angles of this kgh is actually a multiplication of 2k plus 1 of 180 degree. So let's say we have this example here. We have a system and our closed loop transfer function of this system is equals to, okay, so we want to know if point S is a closed loop system pole for some value of gain k. Okay, if this point S satisfy these two properties, which is M equals to 1 and the angle of theta equals to multiplication of 2k plus 1 multiplied by 180 degree, we can say that the point S is on the root locus. Okay, let's say just take some arbitrary point of S. So let's say I want to take this point. This red dot here, which is here, is actually at negative 7.97 plus 10.5 I. Is this red dot is on the root locus? So we can say that this S location is on the root locus if it meets two properties, which is the magnitude equals to 1 and the angle equals to multiplication of 2k plus 1 multiplied by 180 degrees. If these two properties is met, then we can say that this point S is on the root locus. Right. We have, in this case, we have two poles and we have two zeros. Actually, this is this previous example. S plus 3, S plus 4, this is zeros. We have poles at S plus 1, S plus 2. Okay, and we plot onto the S plane. We have a negative 1, negative 2. This is the poles. And then we have zeros at negative 3 and negative 4. So let's say we want to know if this S equals to negative 2 plus j3 is on the root locus or not. So what we can do is we need to calculate whether this point is meet these two properties. M equals to 1 and the theta, the angle is equals to 2k plus 1, 180 degree. What we can do is we take the summation of zeros minus summation of poles. Theta 1 plus theta 2 minus theta 3 plus theta 4. So minus in bracket. So we have theta 1 plus theta 2 minus theta 3 minus theta 4. So the summation of the angle of each of these poles and zeros equals to negative 70.55. From this value, we can summarize the negative 2 plus j3 is not a point on the root locus because it does not meet one of the characteristics. The angle must be in 180 degree multiplication. If we repeat this example, now we have S at this point S here, we can calculate, okay, the summation of angle theta 1 plus theta 2 minus theta 3 minus theta 4. The summation would be 180 degree. So this is a good sign. And we can confirm by finding the other properties, which is, in this case, is K. We find K value. So this is actually comes from these properties. So M equals to KGH equals to 1. And then we have 1 over M equals to 1 over GH to find the K. And then we can calculate using this formula, which is product of pole length over product of zero length. Product of pole length is actually the magnitude of this pole. We have the magnitude is the distance between -1 to S. This is the distance -2 from point S. So what we can say here is we have L3 and L4. So L3, L4. So the magnitude is calculated using this formula. We have -2 minus -1. So the distance here, and a square plus this point to this point. So we have same number. So we have negative square root 2 over 2 square, and then we square root the summation of that. What we have is we have the magnitude of this complex number. So it's 1.22. So we can do for all L3, L2, L1. So what we get is the product of pole divided by the product of 0, which equals to 0.33. So what we can say from this example is this S, -2 plus j square root 2 over 2 is on the root locus, and the value of gain at that position is equals to 0.33. So basically when we know this point, we know that if it's on the root locus, if it is on the root locus, we can find the value of K at this position using this formula. So this, given the poles and zeros of the transfer function KGH, a point in the S-plane is on the root locus for a particular value of gain K if the angle of zeros minus the angle of poles all drawn to the selected point of the S-plane add up to 2K plus 1 multiplied by 180 degree. So this is actually what we have done just now. Furthermore, the gain K at that particular point is found by dividing the product of the pole length by the product of zero length. This is also we have done in the previous slides. Alright, so this is an example. Given a unity feedback system that has the forward transfer function, do the following: A, B, and C. So the answer is already given here. Sum of angles is 180 degree. Point is on the root locus because this met one of the criteria, and K is equals to 10 by finding the K value using the length of vector. We have a product of poles divided by the product of zeros. So I need you to try this on your own. So make sure that you can get these answers A, B, and C. Right?